good day everyone, we are the third group and we will now be presenting our Arduino project, Project Heart, blossoming possibilities, one heart at a time. So this is our version 1.1, this is the demo project of our Project Heart, and we will start by introducing what is Project Heart and what are the backgrounds of Project Heart, which will be explained by Chloe Niña, with Dela.
As of today, the agricultural community has been facing struggles in dealing with their farmlands. However, we're here to introduce our solution, Project Heart, a robot that redefines the future of agriculture. Let's get straight to the point. There are three problems in Filipino agriculture: weak crop yield output, problems in food security, and zero investment in R&D. Agriculture is supposed to be our country's major source for income, but now, Filipinos experience costly food products through the years. Not only does Project Heart have great capabilities, but also has a huge market, with about 30% of the land being used for agriculture and around 5 million farmers to be assisted with the help of Project Heart. What's the big idea? What if there's a prototype for a product that can be used for small-scale purposes that can be integrated by people in their own homes to help with their farming or even gardening needs, enabling them to be sustainable and eco-friendly? But how do we do it? A good way to do this is by prototyping it with electronics, and what better way to do it than with tiny computers that we call microprocessors. Next up, we have Marc again for introduction to Arduino.
So our next topic is all about Arduino. So Ardu what? Arduino means strong friend in Italian and it's developed in 2005 in Brea, Italy by Massimo Banzi and David Guardiani. So Arduino boards and open source hardware uses a processor that is developed by Atmel. So what is Atmel? Atmel stands for Advanced Technologies for Memory and Logic. So the Atmel chips are the ones that are used by Arduino. So in the case of Arduino Uno, it's an Atmel that is on the 32 series. And then for other Arduino, it is on another series of Atmel boards. So coding with our Arduino board is accessible and transferable with both compiler and interpreter languages. So what are the functions of our Arduino? Arduino is great for prototyping ideas because it has an easy access to our input and output. It is also flexible and open source. So flexible meaning that it can handle many sensors as much as possible as long as it has skills, and open source meaning we can use our code, upload it to the internet, and we can share it to everybody. It also runs on low power, which is on 5 volts. So the microprocessor unit of our Arduino can be used to make transducers and sensors that can be controlled. So the benefits of Arduino is the go-to gear for artists, hobbyists, students, and anyone with a gadgetry dream. So anyone can make this actually, our Project Heart. If I make this open source, which is, well, it is easy to make it open source by GitHub, and then share the whole code, then I can upload it to GitHub, and then someone can make another Project Heart, which is version 2, version 3, version 4, or whatever. They can add anything as long as the board can handle it, it's okay. So Arduino rose up of another formidable challenge: how to teach students to create electronics fast. So with Arduino, you can almost control almost everything. So it can be a simple light-emitting diode. So what are the types of Arduino? So the very first Arduino is actually do-it-yourself. So this is actually a replica of a do-it-yourself version Arduino. So the DIY version Arduino uses the Atmega. So it's Atmel, but it uses a Mega 3280P series. And for other EVR boards, so EVR means Advanced Virtual RISC, or Advanced Virtual Reduced Instruction Set Computer. So it's like your flash drive or your MacBook M1. So it uses reduced instruction set computer code or architecture. So that's the point of Arduino. It's closer to flash drives and actually MacBook M1s and actually our phones because it has the same architecture. So there are other types of official Arduino boards. So the official Arduino boards, the very first one is actually the RS-232. So the RS-232 board is like our Arduino Uno, but the RS-232 port is actually the one used instead for USB-B. And then when you replace the RS-232 with our USB-B, you come with the Uno series. You come with the Uno series. So the Uno series, it actually started from 2009 with the 2009. So 2009 means 2009 in Italian. And then the Sinila, which has started in 2010. Then after that, the Uno Type boards are born. Then after Uno, we have our very little version of Arduino, which is the Arduino Nano. And then there's the bigger one called the Mega. So it's actually the biggest Arduino up to date. So as you can see, the Mega has more pins compared to its Uno counterpart and Nano counterpart. So Mega is used for bigger projects and ones that use more sensor technologies. So our other types of Arduino is the LilyPad. So the LilyPad is actually a circular one where you can actually just, tape it and then make it into a circuit and it works. And Arduino. This is our standard Uno. So what does our standard Uno have? So our standard Arduino Uno has a 14 digital I/O pins, and 8 of it can be used as pulse width modulation. And then 6 analog inputs for analog devices, a USB-B connection, a power jack. There is actually a reset button, so you can play the code indefinitely. But then if you want to see something how it works from the start, you can reset it. Then there's an onboard LED. So the onboard LED is actually the power indicator. Then SCL and SDA pins. So SCL and SDA means serial data and serial clocks. So in short, it contains everything that you want to have in a microcontroller. So these are the pictures of our Arduino. And this is actually the pin of our Arduino board. So how does Arduino read? So Arduino is actually 8-bit. So 8-bit means you have a bit here like a 1 or 0. So 1 means true, 0 means false. This is Boolean algebra. And then since it is an 8-bit, you can just count the 4 here and then count the 4 there, and that's what Arduino reads. So if there's an 8 here, your most significant bit would be a 1, and then a significant bit here would be also 1. So meaning this is a positive number if this is data. So if our most significant bit is 0, then it's on the negative side. So these are the bit positions. So this is just binary. This is actually useful in Arduino. So we have our number type. So int, double, string, and actually float. So doubles and strings are just other data types. So strings are mostly phrases or words. So in order to code, we need to download Arduino IDE. And IDE is available for Mac, Windows, Linux. And you need to familiarize yourself with the IDE. This is the old look of our IDE. Arduino signals are either analog or digital. So when I say digital, you can place it on digital pins, and analog, you can place it on the analog pins. When you mistake the analog and the digital, your sensor or the circuit that you have will work. So all computers including Arduino only understand digital. But how do they understand analog parts? So they quantize it. So quantizing means you have a code that runs on analog, so the Arduino will just count it numerically. So basically, in other terms, this is just numerical calculation. So that's what Arduino does in analog. So this is an example of an analog versus a digital configuration in Arduino. Serial because data is broken into bits. So for our serial data, it is actually broken. So when you have data on the serial data, for example, like a put a text on our 16x2 LCD right here, like let's say hello world or something. The hello world is transformed into binary. Then the binary ones are broken. So what our serial data does is it passes all the signals there to the serial data and ensures that it runs in real time. So we have our serial clock. So serial data here and serial clock work in tandem with each other and it works. So our text just prints on our 16x2 LCD. This is the form of our Arduino IDE. So Arduino is usually programmed with embedded C. So it is technically C, but it is on the embedded side. And the void setup part of our IDE here. So in this IDE, there's a void setup and there's the void loop. So for the void setup, you set up all the digital sensors, transducers, whatever. And then for the void loop, it runs indefinitely. So that's something of the void setup and the void loop. And it is at least good practice to be familiar of what the transducer or the sensor can do. So at least you know if it fails or you can troubleshoot it easily. Input is what goes in and output is what the computer goes out. So it's the same with Arduino because technically Arduino is also a computer, but the computer part here is the one with Apple. As you can see, output is always digital. So Arduino technically is the analog, but it quantizes it, and when it quantizes it, it becomes digital. So pin mode is to set whether the pin in the Arduino is input, so maybe it goes in, or output, create let's install. So digital read, so it reads high or low from 8 pin. So high or low is basically 1 and 0. So that's it. Digital write is when you write a value. So we can set it as 1 or 0 in our logic board. So embedded systems, so the meaning is here, and actually this is an embedded system, this one. So I have a bunch of sensors here, then something mechanical, something I can push through, then something electronic inside, and also the reports, this one. So the 8 digital pins there for pulse width modulation is one used for making the signal amplify or making the signal lower. So this is that one. So 100% is full square wave, so it goes like this, then the other goes like this. Then it gets smaller, so it becomes a pulse. So when it becomes a pulse, it's like a line. So beep, 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 beep. Then if it goes to 100%, it becomes a large note. Then digital reading, so this is the one used earlier at the bottom. And the digital sensor, so signal is always high or low, so on or off or 1 or 0. So analog reading, this is the potentiometer, and for analog sensors, we have actually a few. And for analog sensors, it either measures resistance or it actually transduces something or a converter.
Now, for our project design, we have this initial sketch to visualize what we wanted our mini agricultural robot to look like. The duration of this project spans from October to December 2023, from planning to testing phase.
Okay, so we're back again, and this is actually the working version of Project Heart, or at least its prototype, because this Arduino board doesn't work. But as you can see, there's the 1602 LCD, and it should actually show text if the serial data and the serial clock just works on the display board right there at the back, but it doesn't.
As can be seen, in our final product, we weren't able to follow exactly what the initial design intended. Most of its functions, however, are operational. In terms of its functions, we have the following. The ultrasonic, to determine the water level of the surroundings and above ground in the case of flooding or other water sources. Of course, we have our plant here and a cup of water to demonstrate the water level's capabilities. We have the sensor for soil moisture and a humidity and temperature sensor working as well to gauge these important factors in the plant's growth. Attached here are also the LCD to display data of the humidity, temperature, water level, and soil moisture, and the matrix keypad, which is supposedly for mode or language selection, although the speaker does not work as the Arduino is broken or not functional. This is somewhat of a huge loss for our project, as we intended initially for an alert system for when moisture level is too low to indicate to the owner that it is time for watering the plant.
Ho, ho, ho! Merry Christmas!